Hello everyone, I am preparing this video for your ease and observe this video and also give me some comment. If you have any question, don't hesitate to question. If you have any suggestion, don't hesitate to suggestion, because I prepare all of this video and everything for you only, and for getting feedback. And if I get the feedback, then it will help me to make them more interesting. Thank you very much, and have a safe and enjoyable vacations. Yeah, thank you. Okay, today we are going to talk about the atomic structure and also the bonding, relation of the atomic structure with bonding. So before going to atomic structure, we need to know the quantum number, because for bonding we need the electronic configuration, and for electronic configuration we need the quantum numbers. And when we have the quantum numbers, then it is easy to get the electronic configuration. And we know that the quantum numbers there are four different quantum numbers. One is principal quantum number, which is, we say, n, and I will write qn for quantum number. Okay, it will be easier for me to write up and to save some time. So the second one is subsidiary, or we call it azimuthal quantum number, okay, which we represent by L. And the third one is magnetic quantum number, which we say M. And the last one, we call it spin quantum number, and we say S. So there is four different quantum number: N, L, M, S. N is the principal quantum number, L is the subsidiary quantum number, M is the magnetic quantum number, and S is the principal spin quantum number. Now, N always represent the energy level. That means whether it is first energy level, we know the energy level, which is allowed energy level according to Bohr's model. Energy level. L always represent the orbitals in an energy level. M always represent the subdivision in the orbital. In the orbitals. And S always said as spin. Spin means whether electron is moving this direction. We know electron have only two directional movement. One is this direction or this direction. That means clockwise or anti-clockwise. So this is determined by the spin quantum number. So we have four different quantum numbers: N, L, M, and S. N means energy level, orbital, subdivision in the orbital, and then spin. Okay, now if we look at how their values are generated, now so if we consider about the principal quantum number, that means the N. The principal quantum number is basically a integer. Okay, if you consider about principal quantum number n, it is always a integer. Integer means it is 1, 2, 3, 4, 5, 6, 7, 8. Okay, 1 means first energy level, 2 means second energy level, 3 means third energy level, like that. Okay, and then we have the L. So L is the number determine the orbital. Okay, the value of L is basically L equal to 0 to n minus 1. So if L equal to 0 to n minus 1, that means if you have n equal to 0, then L equal to only 0. Okay, 0 to n minus 1, 1 minus 1 equal to 0. If we put 1 minus 1 equal to 0, okay. Now, if n equal to 1, then, sorry, if n equal to 1, then L equal to 0. If n equal to 1, then L equal to 0. If n equal to 2, then L equal to, what will happen? 0 to 2 minus 1. That means 0 to 1. So 0, 1. Okay. Now, if n equal to 3, then L equal to 0 to 3 minus 1, then L equal to 0 to 2. So that means L equal to 0, 1, 2, 0 to 2, okay, 0 to 2, 0, 1, 2, okay, okay. Then if we consider n equal to 4, so 0 to 4 minus 1, so 0 to 3, so L equal to 0, 1, 2, 3, 0 to 3, 0, 1, 2, 3. Okay, so this is basically the way how we determine the value of L. So that basically depend on the value of n. If n equal to 1, then it will equal to only one value, it is 0. If n equal to 2, then it is 0, 1 because L minus 1. And if equal to 3, then 0, 1, 2. Okay. Now, if n equal to 4, then it is 0, 1, 2, 3. Clear? Okay. Now L, I also said that L determines the orbitals. Okay, we know the orbital, you know the orbital. Okay, orbital is basically the region of the area in your orbit where the probability of finding electron is maximum. Okay, if the probability of finding electron is maximum, then we can say this is the orbital. If we, that means L also determine the orbital. So what is the orbital? If L equal to 0, then we say this is a s orbital. If L equal to 1, then we say this is a p orbital. If L equal to 2, then we say it is a d orbital. If L equal to 3, then we say it is a f orbital. Okay, and so on. So if L equal to 0, it is s. If L equal to 1, then it is p. If L equal to 2, then it is d. If L equal to 3, then it is f. Okay. Now consider that. So if we remove all of them, just we'll keep the key point in the board, because you know my board is very small. So it's not too small, but smaller than your institute one. So n equal to, we know that. Now L equal to, we obtain 0, 1, 2, 3 like that, and when L equal to 0, then S. When L equal to 1, then P. When L equal to 2, then D. When L equal to 3, then F. Okay. Okay. Now we have the third quantum number. Okay, what is the third quantum number? It was magnetic quantum number. Okay, the MEM. Now the value of magnetic quantum number, or M, we always obtain it in a set. Like a set, you do the set in the algebra. So this is like a set, N and L. Thus every set of n and l value will yield you a m value. Okay, so that means value of m largely depend on the set of n and l value. Now before going to there, what is the basically the value of m? M is always minus l to 0 to plus l. That means if L equal to 1, then M equal to be minus 1, 0, plus 1. Why we include 0? Because if according to the, you do some mathematics in like we call it the uh, Shankharekha or something. So if you think about that, then if you want to go from negative to positive, then we must have to tackle the 0. Otherwise, going to the 0, you cannot go through the -1 to +1 or -2 to +2. So as a result, we need to include the 0. So the value of m is always -l 0 to +l. That means if l equal to 1, then it is -1 0 +1. Okay, I think it's clear. Now we will look at that. I said again, this value of m largely depend on the set of m and l. So how? Now consider that. Suppose I will go for n equal to 4 and this orbit. So if n equal to 4, then n equal to 0 to n minus 1. So 0 to 4 minus 1. So 0 to 3. So if it is 0 to 3, then 0, 1, 2, 3. Okay. So if we consider about the set, then there will be the set n and l set. So there will be the first set will be 4, and we just delete it. For simplification, we just keep it 0, 1, 2, 3. So for the first set, it will be 4 and 0, 4 and 0. So for the second set, it will be 4 and 1. For the 4 and 1, this one and this one. Okay. So for the third set, it will be 4 and 2 with this one. And for the fourth set, it will be 4 and 3 for this one. Okay. Now for this set, for this set, if you consider about this set, for this set, m equal to -l to +l if we take. Okay. So 0 means 0. Everything is 0. So it is only 0. Okay. So this is basically represent the energy level for S, because m equal to 0 means L equal to 0 means S. L equal to 0 means S, so it is 4S. Now I said m will represent the subdivision in the orbital. So that means there is only one value, which implies S orbital has no subdivision. Okay, it is true for 1s, 2s, 4s, 5s, 6s, whatever. Okay. Again, for this one, we will get m equal to l equal to 1. If l equal to 1, then m equal to will be -1, 0, +1. And if m equal to 1, then it will represent, if l equal to 1, then it will represent 4p orbital. Now, how many subdivision in the p orbital? 1, 2, 3. So we say that p orbital has 4 subdivision. Okay. Now each subdivision contains 2 electrons. So that means p can contain 6 electrons. That means 3 into 2. So maximum 6 electron, and this will be 2 electron. Okay. Then if you equal to 2, m equal to, we can write -2, -1, 0, +1, +2. Okay. Now if n equal to 2, then we know that it is D. Okay. So this is basically 4D. Now how many subdivision in the 4D? 1, 2, 3, 4, 5. So that means there will be 5 subdivision for the XY, for the YZ, for the ZX, and 4d x square y square 4d z. Okay, total 5. So if there is 5, then 5 into 2 equal to 10 electron maximum in the d. Again, if we consider about this one, when L equal to 3, then M equal to -3, -2, -1, 0, +1, +2, +3. So total 7. And this is basically for F orbital. That means F has 7 subdivision, and this 7 subdivision can contain 7 into 2 equal to 14 electron. Okay, so from this one we can determine which orbital basically has how many electron and which orbit can have how much electron. Okay, so we can say that the total number of electron in sp and df, so s can have 2 electron, p can have 6 electron maximum, d can have 10 electron, and f can have 14 electron. This is the maximum amount of electron in these subshells. Okay, now we will determine the electronic configuration. Okay, so before going to electronic configuration, we know that according to 3 different principles, we actually go for the electronic configuration. One is Auber principle, another one is Hund's rule, and another one is Pauli exclusion principle. So Pauli exclusion principle said that there will be, if we consider about Pauli exclusion principle said that if we consider about 4 different electron, if we consider about 4 different quantum number of any electron, then they will not be the same. That means the value of all of them should not be same for any electron in any atom. Jodi, if we consider, suppose there is 4dxy2. Okay, now for n equal to 4, l equal to 2, because d, m equal to, for xy we suppose this is -1 or it is -2. Okay, but for s, if we consider this 2 electron into a and v, plus half will be for a and minus half will be for b. Oh, I forgot about the s value. So s value is always plus half and minus half. Okay, so for m equal to -2, you see all these 3 is good. Okay, they are the same, but when it come here, then for a and for v this is different. So even we consider about the same electron in the same orbital, even in the same subdivision, their number of value of all of the quantum number is different. Okay, and what is Hund's rule said? Hund's rule said that when electron occupy, then they will occupy in highest number of unpaired state. That means if there is 4p2, then there will go 4px1 and 4py1 and 4pz will be 0. Okay, and also another principle which called the, we said that it is, so this is the 2 principle, and another principle which is said that if we consider that I said Pauli and Hund's, and another one is exclusion principle, Moore's rule, and another one is okay. I will tell you when I can remember it. Okay, now according to these principles and all of the things, we arrange the orbital. Oh, electrons will occupy the lowest energy level first, then it will go for the higher energy level. Now, how we determine which energy level is lowest? So for this one, we need to consider n plus L value for each orbital. Like if we say 3D and 4s. Now for 3D, n equal to 3 and L equal to 2. So 3 plus 2 equal to 5. This is the n value and this is the L value. For 4s, n equal to 4 and L equal to 0. That means 4. So basically, though 3D contain into the third energy level and 4s into the fourth energy level, but their energy is for the 4s is lower than 3D. As a result, electrons should go to the 4s first, then to 3D. Okay. So by considering everything, we arrange all of these things. We arrange a arrangement. Okay, you can remember anybody, someone can use it in different way. I just follow this way, that I write 1s here, then 2s, then 2p, after the p 3s, then 3p, then 3d, after the p 4s, 4d, sorry, 4p, 4d, and 4f, and then 5s, 5p, 5d, 5f, 6s, 6p, 6d, 6f, 7s, 7p, 7d, 7f. Okay. Now, okay. So that's it. That's it. So that means 1s, then occupy 2s, then 2p, then 3s, 3p, 4s, then 3d. Okay, then 4p, then 5s, then 4d, then 5p, then 6s, then 4f, again 5d, 6. So that means we need to go according to this spiral line, and then we will get the number of, we will get the orbital or subdivision of the orbitals according to their energy. So now that means if a electron, like it is here, now suppose I want to do the electron configuration of titanium 22. Okay, so if we go, then 1s2, 2s2, so 2 2 4, 4 gone, we have still 18, 2p 6, then 3s2, 3p 6. So how many? 10 and 8, 18, and we have still left. So 3p, so from 3p it doesn't go to 3d, it goes to 4s. So first 4s 2, so we have 20 and another 2 left. This 2 will go to 3d 2. So that means this is our electronic configuration of titanium. It doesn't go that 3d 4 6, it go first 4s, then rest go to the 3d. Because of this arrangement, we need to follow this type of sequence and then find out the electronic configuration. Now I will show you the electronic configuration of some element. So if you consider that, like electronic configuration of, if we go for the, okay, we will go for the potassium. potassium it is 19, calcium 20, scandium 21, titanium 22, vanadium 23, chromium 24. Okay, rest of them will go later. Now it will be 1s2, 2s2, 3s2, 3p, sorry, 2s2, 2p, 6, 3s2, 3p, 6. So 20, 18, only one left, 4s1. So it will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 20. Finish. There is no more. So if you use 6 plus 2, 8 plus 2, 10, 12, 18, 20. For this one, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Now there is another one left, so it will go to 3d1. Now for titanium, it will be the same as this, and it will go to 4s2, 3d2. It will be 4s2, 3d3. It will be 4s2, 3d4. But we know that the orbitals are totally stable when they are fully filled, but they are similar stable or show the similar stability nearest to that when they are half filled. Now whenever you have this type of condition, that 4s2 3d4, then it always sacrifice one electron, it gives 4s1 and make it half filled, because the orbitals are stable at full filled or half filled. So if it sacrifices, it is half filled, then it is also half filled. So both of them are happy. Okay, so they are not human beings. They are not trying to snap the happiness from others. They try to make others happy. This is the nature, who always try to make others happy, not himself happy. Okay. Now chromium. Then we can go for our chromium. Manganese, which is 25, iron 26, then cobalt 27, nickel 28, okay, copper 29, zinc 30, and then arsenic, then okay, then we have 31, 32, 33, 34, 35, 36 up to, okay, 35 bromine, and then 36 krypton. Okay, okay, now this will be 4s1 3d5, then this will be 4s2 3d5, this will be 4s2 3d6. Gradually if we go like that, then finally it will be 4s2 3d10 4p 5, and it will be 4s2 3d10 and 4p6 with this one, the last one. So that means if we know that, then we can arrange, we can get the electronic configuration of any atom. Now, from this electronic configuration, we also can get the position of any element in periodic table. How? So if it is 4s1, that means this is a 1a group, or in the modern periodic table it is 1, and the period number is always the highest number of the group orbit, that means 4. For this one it is 2a or 2. For this one it is 3a or 3. Now 3b. Why it is 3b? Because whenever the electron enters into 3d after 4s, then it will go for the b subdivision. That means the d block element always go for the b subdivision. And 3. For this one it is 4b and 4. For this one it is 5b and or 5. For this one it is 6b or 6. Okay. For this one it is 7b or 7. For this one, for these three, all of them are 8, group 8. Or if we say modern, then this is 8, this is 9, and this is 10. And for this one it is 4s2 3d 4s1 3d10, and for this one 4s2 3d10. So as 3d is 10, for the previous periodic table system we do not count the 3d electrons, so it will be 1b. For the modern it will be 11. For this one it will be 2b and 12. Okay. For this one, this is actually the 3a. This is 3 or 13. This is 3b or 14. This is 4b or 14. This is 5b. Sorry, 5a. All of them are a. Sorry. Or 15. This is 6a or 16. This one is 7a or 17, and this one is 8. This is V, this is A, or you can say 0, or this is group 18. Okay, so this is how we can also determine the period of any element from this type of electronic configuration. Now, how electronic configuration lead us to the bonding? Okay, so I hope you all get this point. Now in the next video I will talk about how electronic configuration lead us to the bonding, and how bonding lead us to the structure or the properties of any compound or anything. And wait for the second video, and I will deliver that message in that video, and I hope you understand. So today what we learned, first of all, the quantum numbers, the value of the quantum numbers, the significance of the quantum numbers, how quantum numbers determine the electronic configuration, and how this electronic configuration lead you to the what? To periodic table. And in the next video we will learn how this electronic configuration will help us to learn the chemical bond and bonding patterns. Okay, thank you.